Good morning all. So in this research class we will be discussing regarding measures of relationship. As we know that there are lot of relationships between the measures. So first one is correlation. So if the change in one variable appears to be accompanied by a change in the other variable, the two variables are said to be correlated and this independence is called correlation or covariation. Once again, if the change in one variable appear to be accompanied by a change in the other variable, the two variables are said to be correlated and this interdependence is called correlation or covariation. Other name of correlation is covariation. If there are two variables are there and one variable will accompany the change by other variable, two variables are changing. So because of the one variable change, other variable also getting change. Because of this interdependence, we can call it as correlation or covariation. For example, to understand the relationship between birth weight of newborn and gestational age, characteristic measured in the same person such as weight and cholesterol, weight and height. At the other times, the same characteristics measured in two related groups such as tallness in parents and tallness in children. So in first example, to understand the relationship between birth weight of newborn and gestational age. So birth weight of newborn and gestational age having the relationship. So to understand that one, what we will do? Characteristic measured in the same person such as weight and cholesterol, weight and height. Other example is we have to see the relationship between the weight and cholesterol and weight and height. In other example, same characteristics is measured in two related groups, that is tallness in parents and tallness in children. So we are measuring the same characteristics, as we know that one variable will depend on the other variable. So in first case, we know that there is gestational age and birth weight is having the relation. So to understand that one, we will see first birth weight and gestational age also we will assess. And next one is for same person weight and cholesterol level and weight and height we will assess. In other one example, tallness of parents and tallness of children we will do. So the study intelligence quotient in sisters and brothers we will do. Degree of heaviness or obesity in parents and their children. So the studies are goes on. If only two variables are involved, it is called bivariate correlation. So I told you different variables are there. So in some studies, only two variables are involved. So we can call it as bivariate correlation. And if more than two variables, we can call it as multivariate correlation. So two variables are involved, we can call it as bivariate correlation. And if more than two variables, it is known as multivariate correlation. So meaning of correlation coefficient we will see. To measure the degree of association or relationship between the two variables quantitatively, an index of relationship is used and it is termed as coefficient of the correlation. So to measure the degree of association, we have to measure the degree of association, or we have to see the relationship between the two variables quantitatively. We will make one index relationship. So that term is termed as coefficient of correlation. Coefficient of correlation is a numerical index that tells us to what extent the two variables are related and to what extent the variations in one variable changes with the variations in another. So in coefficient of correlation, what data we will get? It is a numerical index. That particular numerical index will tells us that to what extent the two variables are related, till the which extent the two variables are related, and what extent the variation has happened between the when one variable changes with the variation to the other. So the coefficient of correlation is always symbolized either by small letter r or small letter p. The notion R is known as the product moment correlation coefficient or called Pearson's coefficient of correlation. The symbol P, that is rho, it looks like P only, rho, is known as rank difference correlation coefficient or Spearman's rank relation coefficient. So the notion small letter r is known as the product moment correlation coefficient or Carl Pearson's coefficient of correlation. The symbol rho, which looks like P, is known as rank difference correlation coefficient or Spearman rank relation coefficient. The size of small letter r indicates the amount or degree of extent of correlationship between two variables. The value of small letter r varies from +1 to -1. Direction. The sign plus or minus of the correlation coefficient indicates the direction of the relationship. A correlation coefficient between 0 and 1 indicates a positive or direct relationship. Correlation coefficient between 0 and -1 indicate a negative correlation or inverse relationship. Strength. The absolute value of the correlation coefficient, that is R, indicate the strength of the relationship. Modulus of R indicate the strength of the relationship between the variables. For example, a correlation coefficient of -0.65 is stronger than a correlation coefficient of 0.60 because the absolute value of -0.65 is greater than the absolute value of 0.60. The correlation coefficient closer to -1 or +1, the stronger the correlation. There are no hard and fast rules for constitute strong, moderate, and weak correlation. Some rough guidelines will be telling to you. So, absolute R, that is greater than or equal to 0.9, is very high correlation. Absolute R, that is -0.7 to 0.9, is high correlation. 0.5 to 0.7 is moderate correlation. And -1 to 0.5 is, we can assume that it is a weak correlation. Then there are statistical tables available to see whether the correlation coefficient obtained is significant statistically. If the obtained correlation coefficient is greater than the statistical table value for correlation coefficient R using the degrees of freedom, there is significant relationship between the variable. If the obtained correlation value is less than the statistical table value, the relationship is not statistically significant. So, hope you understood. We had seen regarding the measures of relationship, that is correlation. Then we had seen some of the examples. Then meaning of correlation we had seen to measure the degree of association or relationship between two variables quantitatively. An index of relationship is used and it is termed as the coefficient of correlation. Then R means it indicates the amount or degree or extent of correlationship between the two variables. The value of R varies from +1 to -1. Hope you understood. Thank you.